Last section of chapter 8 has us looking at covalent bond strength, where the strength of a covalent bond comes from, related to the sharing of the electrons. So most simply, the strength of a bond is measured by determining how much energy is required to break that bond. So when you think of chlorine gas up here, the bond strength, or the strength of that covalent bond, those two electrons shared by the chlorine atoms, is equivalent to how much energy it takes to break that bond. And this is what is also known as the bond enthalpy. So this is the bond enthalpy, energy associated with breaking that bond. So the bond enthalpy for the chlorine-chlorine bond here is measured to be 242 kilojoules per mole. So it's an enthalpy. There's an energy associated with that. So the table in your book has the average bond enthalpies for a variety of bond types. Okay, and you can see you've got sets of single bonds, and you also have a variety of double and triple bonds, and you can see how those energies increase when you get double and triple bonds versus single bonds. The average bond enthalpies are positive because bond breaking is an endothermic process. It takes energy to break a bond, and then when bonds are formed, energy is given off in that process. So these are average bond enthalpies, not absolute bond enthalpies. So like a carbon-hydrogen bond in methane will be a bit different than the carbon-hydrogen bond in chloroform. So it really is dependent on specific bonds and specific molecules with what the bond energy will be. But the average bond enthalpies will get us in the ballpark if you're using those to determine like the energy of a reaction. So how might we use the enthalpies of reaction or bond energies to figure this out? So another way to estimate the enthalpy of a reaction is to compare bond enthalpies. So look at what bonds are broken and what new bonds are formed to figure out what the overall enthalpy of reaction is. So in this example, we have methane combining with chlorine gas to produce a chlorine bonded onto a methyl group. So we have to break two sets of bonds. We have to break a carbon-hydrogen bond on the methyl group and break the chlorine-chlorine bond on the chlorine molecule. So way to do that, similar to what we did when using like delta H's of formation, but this one we're using the bond enthalpies of bonds broken minus the bond enthalpies of bonds formed. So we basically would take those values from the table and reverse the signs when bonds are formed, and then the overall value would be the enthalpy of your reaction. So in this example, yeah, I kind of already went through the types of bonds present. So you have the energy of the carbon-hydrogen bond plus the energy of the chlorine-chlorine bond being broken, minus the energy of the carbon-chlorine bond that forms and the hydrogen-chlorine bond that forms. So we plug in those values, and we end up getting that this would be that the delta H of this reaction using bond enthalpies would be minus 104 kilojoules. We can also measure an average bond length for different bond types. So single bonds versus double bonds versus triple bonds have different bond lengths. And those are going to vary depending on the molecule, but they'll be similar. And obviously, as you go from a single bond to a double bond to a triple bond, the bond lengths are going to decrease in that process. So that's it for chapter 8. And we will finish up in class tomorrow and then have a quiz on Thursday regarding chapter 8 content. And then we'll be moving into chapter 9 and looking at molecules and geometry of molecules, looking at how bond structure informs that. So